We are going to talk about adding and subtracting fractions with pictorial models, with picture models. So, looking at this first. Okay. So it says, who wants to read it? Anybody? Go for it, Braden.
Clarence has a dozen eggs. The model below is shaded to show the fraction of the eggs. The clearance used each day for 3 days. What fraction of the dozen eggs did Clarence use over the 3 days?
Okay, so let's first start by writing the fraction he used for each day. So looking at day 1, how many total parts are there in that picture?
One.
There's more than one.
One.
There's one that's shaded, but if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
112.
So I have 112 he used on day 1. Okay. On day 2, how many did he use?
2.
Okay. You're writing what I'm writing. In day 3, how much is 1 half? 1 half.
1 2.
No, 1 half.
Stop. Okay. Now it says to write an expression to represent the fraction of dozen eggs Clarence used over the 3 days. What's an expression? Tell me, Della.
An expression is a way of saying something.
In math terms, what's an expression?
Oh.
Talent. Basically, the equation I'm going to use to solve this problem, right? So to solve this problem, what would I do? Figure out how much you use, Kate?
Would you use a ratio table?
I would, but what would the expression or the equation be to solve this problem first? Brock?
Never mind.
You can do it. If I want to figure out the total amount of eggs he used during these 3 days, what would I do?
Oh, add them.
I'm going to add them up, right? 112 plus 2 6 plus 1 half. Okay, so Kate said that I'm going to use a ratio table. Why did she say that?
They're all the same.
What aren't the same?
The denominators.
Denominators. And when I have adding or subtracting fraction problems, I have to have common denominators, right? Well, I'm going to show you how to use this picture to solve it without having to make a ratio table, okay? So if you look, you can see that this line is even with this line, right? This one with this one. All the half is the same here. So I'm going to take and I'm going to extend these top lines all the way down. So I'm going to take and extend that down. Extend the next one all the way down. The third one. And I'm going to go through all the lines doing that. So if you have 2 or more pictures that are divided up and their halfway marks all line up, then you are able to do this. So everyone go ahead and extend those lines. Give you 30 more seconds. Okay, we ready? Thumbs up if you need more time. More time? Okay, quickly, quickly. Ready? Okay, here we go. So looking at day 1, how many 12ths do I have?
1.
I still have 1 12. On day 2, what is this divided up into now?
4.
They're divided up into 12ths, and I have 4 shaded, yes. So that tells me that 2 6 is also equivalent to what? 4 12ths. Okay? Day 3, they're divided up into what now?
6 12.
12ths, and I have 1, 2, 3, 4, 5, 6 shaded. Which tells me that 1/2 is equivalent to
6 12.
what's equivalent mean?
The same.
The same or equal to. Okay. So now I'm going to go down here and write my equivalent fractions and add them up. Am I able to add this up now?
Yes.
Why?
But they have the same denominator.
They have the same denominators. Okay. So 4 and 6 is 10 plus 1 is 11. Do I add my denominators?
No.
They stay the same. So he ate 11 12ths of his eggs.
And a dozen is 12.
He really liked his eggs. In 3 days, that's a lot of eggs.
Yep, Clarence loves eggs. His mother.
I don't know.
He lost
It's still in the cart.
He kept
Are there any questions on how I extended those lines? And why I was able to do it?
Oh,
Well, let's look at the next paper I gave you.
whoa.
That's a great question. He asked if we could simplify this problem. Let's check real fast. Hold on. So turn to this or follow along with me. So I'm starting in the very top corner. I'm looking for what number? 11. Okay, here's 11, but do I have a 12 underneath it?
No.
Okay. Do I have an 11?
No.
On line 2?
No.
There's not an, on this line right here that starts with a 2, there is not an 11.
No.
Line that starts with a 3. God, honey, look, if I'm looking on this row right here, there is not an 11.
I'm confused now.
I'm going across. Starts with a 3, line 3. Is there an 11?
No.
Okay. Starts with a 4, line 4. Is there an 11?
No.
5?
No.
6?
No.
7?
No.
8?
No.
9?
No.
10?
No.
11?
Yes.
Is there a 12 underneath
Yes.
it? If I go back across, it's
No.
equal to.
11 12.
So
You
can
can't
I
simplify.
simplify it?
No.
That means that this is the simplest form. That is a simplified version of that fraction. Great question. Okay. Hold on. Guys, please stop talking. Okay. Looking at the Kara and Marcus. Shared a candy bar. The models are shaded to show the fraction of the candy bar each of them ate. What fraction of the candy bar did Kara and Marcus eat all together? So there's 2 ways you could do this. You could take your fractions, make a ratio table, find a common denominator, and add them up. Or you can take and draw your lines out like we did in the last problem. Let's go ahead and use this picture and draw our lines as we're practicing that right now. Everyone is doing the lines. And I'm able to do the lines because if I look, the halfway mark here and the halfway mark here is lined up. This is lined up right there. Typically, if you have a picture like this, you will be able to draw the lines down.
Is it 11 plus?
I have to look in a minute.
That was so
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
8 over 12.
How many are shaded?
8.
There's 12 parts for Marcus. How many shaded?
3.
8 plus 3 is?
Can it be simplified?
Can it be something?
No.
Nope.
That was so hard.
So there's that problem.
That was easy.
This is the same. Why is that so hard?
Oh, that is the same problem. Sorry.
Yeah.
It is?
Oh.
It's not that.
It's not the same thing.
Well, my fault.
Can I do it anyway?
Ignore that one. Go to the back.
I already did it.
Hey, I need you to stop talking, please. Okay. On the back. The shaded part of the model represents a fraction. Another fraction was subtracted from the first fraction. Which expression does this model represent? This one's a little more complicated. Okay, so I first want to find how many total squares there are in this picture. There are how many? 15. Okay, there's 15. How many are shaded?
6.
No, there's 11 shaded.
There's 9 shaded.
There's 11 shaded. 11. And then there's 6.
1, 2, 3, 4, 5. Besides, hold on, please stop.
That's 5.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 are shaded.
And not bad. But what about the ones that are still?
Hold on, we're gonna get to that.
That's what we did.
Hold on. This part is where it gets a little confusing, so please listen. So first thing I want you to do, look at my answer choices. Which can I eliminate off the bat?
H.
H, why?
Because it only says 6, 15.
It's not showing the total amount shaded, so I can get rid of this.
And G, because it's saying 12 as a denominator and it's actually.
Very good. I can get rid of G to say I only have 12 total. I know I have 15. So now I already have a 50% chance of getting this question correct. Okay, now let's talk about where the next part comes from.
Okay.
There are 1, 2, 3, 4, 5 columns, right? I'm looking at my columns because it is showing that they're marked out this direction. So I have, this would be 1/5. This would be 1/5. This would be 1/5. 1/5. 1/5. How many fifths are crossed out?
How are they fifths if it only goes 3 down?
But there's 5 rows.
There's 5 rows.
If they were turned this way and crossed out long ways, they would be what?
1/3.
They would be, hold on. If they were crossed out long ways, there would be how many rows? 3. So I would have 1 2/3. They are crossed out going this way. That's 1 column, 2 columns of 2/5. Confusing?
No.
Really, it's not? Are y'all just telling me that?
No, it's not. It's actually I'm doing wrong.
So I have how many that are crossed out?
2.
2
So
fifths.
that would be 2 fifths.
Even if I did not understand the second part, do you think it's 1/6? Would 1/6 even make sense?
No, you multiply 5 and it would be 6.
That would make sense.
1/6 would not make sense because if I said there's total of 15, 1, 2, 3, 4, 5, 6, this would not simplify down to 1/6. Y'all need to look up here. I'm going to put does not equal 1/6. So that could not be a possibility. So this is why you need to say, okay, I know it's not G, I know it's not H. Now a 50% chance of getting it right. Does it make sense that I'm subtracting 1/6?
No.
There's not a way. Now if this simplified down, that would be confusing, okay? But that does not simplify down to 1/6. Wait. So what is my answer?
Yay.
Okay. There are not that many questions on STAR like on this topic. These two questions are the only two that I've been able to pull off really STAR tests. So it's not tested this way very often. Okay? Does that make sense? Okay. Okay. So let me pause, turn the video off so I can show you how to glue it in now.